Hello everyone, this is Varun Subramaniam and this is my arc length project for AP Calculus AB. So just some background. I enjoy going to the Woodridge High School field with my friends to play soccer or baseball, and almost every time we're there we end up racing each other, and the race starts at the start of the end zone and loops around the goalpost and comes back to the finish. So we usually assume that it's only a 240-yard run, but we don't count going around the post in our length. So the purpose of this is twofold. The first is to find out exactly how many yards the path that we're running is, and also to find out how many laps around this path I have to do in order to run 500 meters. So this is the path right here. As you can see, we start right about there, go down straight path, loop around the goal, again straight path, and come back to the start. So in order to find the length of this, these two sides right here are 360 feet. A regulation football field, its length is 120 yards. So that's 360 feet, and we're running this straight path 2 times. So in order to find the length of this, it's equal to 2 times this 360 feet plus these 2 parabolic pads at the end. So ideally, like I said, we want to be running a parabolic path around this goalpost with the vertex being at the center of the field. So you can see this is essentially the same thing. Of course, it's not as smooth or perfect because I did do this line by line with the line tool from Google Maps. So the first thing I need to do is make a coordinate plane using this in order to find the equation for this parabola. So the first thing, like I said, I have to do is draw my axes, with the y-axis being here and the x-axis being here. So you can see that the thing that we're looking for right now is the equation for this parabola right here under the x-axis. So in order to find the equation for this parabola, I need some points. So obviously this point right here is going to be our start, or 0, 0. And we're going to find 2 other points. Our 2 other points are going to be this endpoint right here, as well as the vertex. So I'm going to find this by using the ruler tool in Google Maps. So the first point I'm going to find is this endpoint right there. So I'm just going to use the ruler tool and measure this distance out, and you can see I get approximately 57 feet. So that point right here is going to be 57, 0. The next point is finding this vertex. So what I'm going to do is I'm first going to find the x-coordinate by doing the same thing and just drawing a line out to the center. And again, just something to clarify, because of the orientation of this map, the center actually isn't where this goalpost is, but rather where this small line is. So I'm going to be looking at the center of that to determine where to stop. Again, this is just because of the orientation of the map. So you can see I get 28 here. So our x-coordinate is going to be 28. And to find our y-coordinate, we're just going to go straight down to this end, and we get 40. Since this measuring tool is additive, 40 is actually not our y-coordinate. Rather, what we have to do is subtract that from our x to get 12. So our vertex point is going to be 28, 12. Right there. Nice. So as you can see here, I have all the points I need. So I have 0, 0, 57, 0, and 28, negative 12. Again, this is negative because it is below the x-axis. And so now what we're going to do is I'm going to use a tool called Graph, which is a regression tool. And this is going to help us find our equation for the line. So the first thing I'm going to do is just change our windows a bit so that we can view everything. Next thing I'm going to do is plot those points, or rather enter those points. So 0, 0, 28, negative 12, 57, 0. And as you can see here, it's extremely similar to our parabola right about there. So next what I'm going to want to do is insert a trend line right there. And so now I'm going to go to polynomial, and I'm going to choose a second order because that's just due to the number of points that I have on there. Click OK, and as you can see, it adds this trend line connecting our points and essentially gives us our equation for this graph. So I'm just going to double click here for our equation, and as you can see, this is the function of the equation right here, this long nasty function. So I'm just going to copy that for later use. So now we go back here, and as you can see, we have our function value. So now to find the derivative, I'm just going to go to Wolfram alpha. Really a great thing. There's a derivative of that, our function that we found from earlier, and we get this as our number. So again, I have that copied right there, and now we're ready to use the arc length formula. And so the arc length formula is the integral from a to b, being our limits of integration, of the square root of 1 plus the derivative of our function value squared. So now to find the length of that parabolic function, we're just going to plug in our derivative, and our limits of integration are going to be 0 and 57 as per this graph right here. So that's our start and finish. And you can see that we get a length of approximately 63.2. So this brings us back to our original question, the true length of the path. So we said earlier that the length is going to be 2 times 360 plus 2 times the length of this parabolic path. And we know that this parabolic path, thanks to the arc length equation, is going to be approximately 63.2. So we just plug that in, and we get our true length as 846 feet, or approximately 282 yards. And you can see the accuracy of this equation. I'm just going to double click here, and you can see that our path is 860 feet, and I measured 846. And again, some length is lost because this is not a perfect curved line with the vertex at the center. So obviously there's going to be some discrepancy there. But you can kind of see the accuracy of this arc length formula by kind of looking at the percent discrepancy or percent error. And we get a 1.63% error, which is statistically significant or statistically acceptable. So you can see that this formula really does work. And so back to our second question, how many laps would I have to do to run 500 meters? So using some handy dandy dimensional analysis, converting meters to feet and the amount of feet in one lap, we get 1.94 laps. So I'll have to run approximately 2 laps for 500 meters. So as you can see, I didn't have to go and kind of measure using a ruler or measuring tape this entire field. I used calculus to solve for this length. And that's the power of calculus. So you can see that this has some real life application if you ever want to find the length of something using arc lengths. Thank you very much. Have a swell day.